Hi, it's Doug. Imagine if you lived your whole life without ever leaving your town. If you live in the mountains, you never see the ocean. If you live by the ocean, you'll never see the mountains. Imagine the country where you live is the only country you'll ever visit. That would mean, unless you're within walking distance, you'll never get to see things like the Hollywood sign or Disney World or a sunset at the Grand Canyon. You'll never get to visit the Eiffel Tower in France or the Great Wall of China. You'll never see the Great Barrier Reef of Australia. It's kind of sad to think of never having a chance to see any of these things, right? But if you lived in pretty much any other time in history, that's what it would have been like. Long distance travel just wasn't possible. People were pretty much stuck wherever they were born. If they did travel, the journeys were slow, uncomfortable, and sometimes even dangerous. Luckily, travel today is easier and cheaper than ever. It's so easy, we often take it for granted. But stop and think about it. What's one distant place that you'd like to visit in your lifetime? How would you travel there? A long time ago, if you wanted to go somewhere, you had to get there by foot. Like, imagine you wanted to travel across an entire continent, like from one side of North America to the other. On foot, that would take you about 6 to 8 months. A journey like that took such a long time and was so dangerous and difficult that it wasn't really a trip that most people took. Before long, though, people realized there's a better idea. Why not hitch a ride on an animal instead? That's a big improvement. Riding a horse, for example, doesn't require nearly as much of your energy as walking does. Plus, you could hook up a cart or a wagon to carry things with you or move several people at a time. Now, on a horse, people could go from one side of the continent to the other in only about 3 to 5 months. That's definitely a lot better than 6 to 8 months. But it's still such a long time. There were also new challenges that came along with having animals to carry you or pull a wagon for you. Now you had to care for them, bringing them to fresh water and letting them rest. Plus, you had to get food to feed them, like oats or hay, plants that had to be grown. It took a lot of work planting those crops and then harvesting them. And that's not even food people got to eat. That was just the food for the horses. Surely there must be some better way to get around, people thought. In fact, you know that there's a better way. Things we use for travel today, like airplanes and cars and trains, but these weren't invented until the 1800s and the 1900s. Each one is incredibly complex, made of many different parts working together. These machines weren't just thought up overnight. It took many years to develop them into what we know today. But it still seems like a big jump. How did we go from having to travel everywhere on foot to riding animals to then having amazing machines like cars and trains and airplanes? It turns out the first clue was actually discovered more than 2,000 years ago. An ancient Greek inventor named Hero came up with a toy, a little device like this. You could take off the top and fill it with water. Then you can heat it over a flame. What do you think will happen? Watch. Let's see that again. When the water begins to boil inside, it becomes steam, which builds up inside the container. Then the steam shoots out of the openings on the sides of the container. Since the openings are angled a little bit, the container starts to turn and spin. No one, not even Hero himself, thought about using this device to make it easier for people to get around. For Hero, it was just something fun to play with and show off to friends at parties. But does it have potential to help people get around? How could this be useful to people? What do you think? In today's activity, you're going to make a machine that uses heat to make a spinner spin. In the first part of the activity, you'll make a spinner and a spinning support tower. In the second part of the activity, we challenge you to use heat to make your spinner spin steadily. To do that, you're going to have to think like an inventor. Inventors experiment and pay attention to what happens. And just as important, they pay attention to times when nothing happens. Sometimes the only way to figure out why something works is to see where it doesn't work. I'll show you how to get started experimenting step by step. Before we do some experiments with heat, you're going to get to know your spinner.
Because we're doing this at home as a demo, I'm going to help demonstrate what happens with each of these different parts of your heat spinner. So if you have the sheet right here that your teacher maybe shared out with you in a digital form, you can use that. If not, we are going to be recording our ideas as to what happens with your spinner. So make sure that you either get this document or have a notebook where you can write things down. So we'll talk through as we go. If you look, what we're going to do first is breathe gently on the spinner from one side and see what happens. Then we're going to blow down, straight down on the spinner, see what happens. Then we're going to talk to the spinner and fan it with, I'll fan it with my hand. And then for the second part, what we're going to do is we'll lift the cup straight up and put it straight down. So we'll do that motion and see what happens to the top of the spinner. Then we will, I'll pick up the spinner and I'll blow upwards through the cup and see what happens. So let's go ahead and get started. The first thing we're going to do is I'm going to breathe on the side of the spinner very gently. So I'm just breathing in and out gently. And if you notice what's happening to the spinner, so I can breathe with my mouth closed or open. Notice what's happening with the spinner. Next, blowing straight down. And think of how the spinner looked different when we blew straight down than when I was breathing from the side. And then next we're going to talk to the spinner. Hi, my name is Miss Adamat and I am playing with a heat spinner and trying to see what kind of things happen when we talk to the heat spinner. So far, it seems like when I say words that start with a T, turtle, turkey, or a P, popcorn, platypus. Whoa, let's try that again. Popcorn. I like popcorn and pancakes and pizza. Here I'm fanning the heat spinner, which means I'm taking my hand and trying to move the air around it. I'm not touching the spinner at all, and I'm not trying to wiggle with the hand that I'm holding it, but I'm trying to see if I can get the air around it to make the spinner move. And you can see the direction that I'm fanning, what happens. The next thing we're going to do is what happens when we move the spinner up and down. So pay really close attention to the star that's on the spinner, and then you can kind of focus on one of the blades at a time. So notice as we move the spinner up, and then when we stop and move it back down, there should be something you're noticing about the direction of the spin on top. So make sure you pay attention to that as the cup goes up and then as it comes back down. Another thing that we're going to do is look at what happens when we blow through the cup. So notice the speed, if I'm blowing up through the cup, that we can get that spinner to move. So here's something for you to think about. What is it that pushed on the spinner? So when we were getting the spinner to move, what actually was pushing on it to make it spin? And next, do you think you have ideas about how might we use heat energy to make the spinner move? What might be special about that? So we're going to have you pause the video and do some really good thinking, record your thinking in your notebook or journal, wherever you are keeping track of your ideas. What did you notice and what do you think? So we're going to take a look at some of those things before you start the video up again, and then Doug's going to talk a little bit about what they noticed when they did the heat spinner activity.
In case it's helpful, here are some things we noticed. You can make the spinner move by blowing on it, by fanning it, or even by talking at it. You might find out that some words even make it spin more than others. The spinner moves because talking, blowing, and fanning all make air move. That moving air is what pushes on the spinner and makes it spin. When I pick up the cup, I do have to move it slowly to keep the spinner balanced on the pin. But once I get the hang of it, I can make the spinner move by lifting it up or by lowering it. By moving the spinner through the air, I made the air push on the spinner, and that made the spinner move. Did you notice that the spinner turned in one direction when I lifted it up, but then turned in the other direction when I lowered it? The direction of spin depends on which way the air is moving. Now, you're going to try using heat to make your spinner move. As you experiment with heat, be sure to move slowly and cover or shield your nose while you're breathing or talking. A sudden movement or breath of air can change your results.
We're going to move on to the inventing a heat engine. Hopefully your teacher shared this document digitally with you. We're going to look at the first part on top is discuss and invent. So you have some things to think about and ideas to come up with and some other activities to do. And then we're going to move on to the experimental part, and I will help you with that part. So the first one is watching the video and seeing what you think could be making the spinner move.
When you're doing question 1 on your worksheet, watch this.
After you have all of your good thinking written down and recorded, we are going to move on to what would have been an experimental station, but we're going to do some observations from what I noticed when I had the heat spinner and eventually involve a heat source, which in this example, I used a lamp for the heat source. So we could have used other things, maybe some really hot water or maybe a space heater. I have a space heater in my house, but I chose to use a light bulb, and it's one of those light bulbs that gets warm. So for the experimental station, I'm going to take the heat spinner and we'll put the top on it and make some observations. Let's go ahead and get started. If I just hold the cup and I don't even breathe on it, look what's happening. I wonder if I let go of the cup. I'm going to try this. I'm going to put the cup on this paper. Woo. So that was an interesting observation. If I hold the cup, oh, I guess I'm wiggling. So if I hold the cup on here, watch what happens when I touch the cup. What if I take this away? Whoa. That's really cool. I'm holding onto the cup. I'm not breathing on it. See? I'll put this up. I'm not even breathing on the cup. Look what's happening. Wow. Okay, I'm going to set it down and not touch it. Now if I just hang on to it, but if I lift it back up and hang on to it, Oh, that's really cool. So can we think about what's happening right now? Oh, now it's not doing anything if I hang on to this. Maybe one hand's warmer than the other. Whoa, I think we need to do some more investigations with the light. Wow, this is really cool. All I'm doing is holding on to it. Oh my goodness, this is really cool. Now watch this if I set it down. So hanging onto it, sitting down. If I open up the bottom by picking it up and hang onto it, look what happens. That's even more fun than blowing on it. Wow. So that makes me think if we're going to do some experiments with the light bulb, I probably shouldn't hold on to it. Or maybe I should, I don't know. Golly. Wow. Look at it go. So put the spinner next to something hot. But I'm not even doing anything yet. All right, let's turn on the light bulb. I should let this get warm. Ooh, it's already getting warm. Okay. Next to something warm. But it was already moving. I'll let that warm up a little bit. It's already moving because I'm holding it. That we just noticed. You know what I should probably do is what if we put the warm thing next to it? Now I know it was already, oops, here. It was already moving before because I was holding it. So if I just hold it over here, okay. So here's the speed it goes just by holding it. Then if I put it over the light bulb, so again, here's the speed it goes, and then on. Here's next to the bulb. Below the hot thing. And I'm still hanging on to it. I know, what if I hold it with this ruler? Here, I'm gonna do something. There, that's more of a fair test. Okay, here. Next to the warm thing. There are a couple other things to look at on the bottom here. Were there spots or times when the spinner doesn't really turn? I think we had some time when you noticed that the spinner wasn't turning. And when it did turn, that it turned pretty quickly and at least 30 times. So record your thinking. What did you notice? What did you think? And then you can pause the video to record those ideas and then go ahead and start the video again, and we're going to hear from Doug about some final thoughts regarding heat energy and the different way that it can help us with transportation.
In the activity, you created a heat spinner that transforms heat into movement. Your spinner started moving when you held it over something hot, like a light bulb in a lamp or a cup of hot water or a heat pack. Maybe you noticed your spinner didn't spin as much when you held it beside the heat source or below the heat source. Why is that? Well, you probably know that hot air rises. This is also why hot air balloons float. There's a source of heat inside the balloon, and that heat rises. You know, in a way, you can think of your heat spinner as a kind of chain reaction machine. Something hot, like this light bulb, makes the air nearby it hot. As that hot air rises, it pushes on the spinner. Then the spinner moves. Take a look at Hero's toy again, but now consider it in the same way, like a chain reaction machine. Step 1, fire heats up water inside the device. Step 2, water starts to boil and turns into steam. The air and steam inside are super hot. Step 3, that super hot air and steam rush out of the device through the pipes on either side, and that makes it move. At each step, energy is transferred from one part to the next, from the fire to the air and water to the container. The device starts with a source of heat and ends up with movement. Heat can cause things to start moving. So heat is yet another form of energy. Today, scientists have a special name for any device that turns heat energy into movement. They call it a heat engine. Hero's device is known as Hero's engine. Hero may have built it just for fun, but over 2,000 years later, it inspired inventors to develop a heat engine that was even more useful. The steam engine. This video shows a miniature version of a steam engine someone created out of glass, so that you can see what's going on inside. It does the same basic thing as Hero's engine. First, a flame is lit under a container of water, which starts to boil. Heat makes steam and air rise and move through the tubes. Then the steam pushes on a piece in here back and forth, which pushes on a rod that's connected to the wheel. Each time this container fills up and releases steam, it turns the wheel. Check it out. By attaching steam engines to the wheels on trains, the steam locomotive, or modern train, was born. This meant, for the first time ever, people could travel across an entire continent using machines instead of on foot or being pulled by horses. Using a steam engine, a trip from one side of North America to the other, a trip that used to take 6 months, now could be completed in only 4 days. And you know that's not the end of the story. Travel has only continued to get faster and cheaper, with modern forms of transportation like cars and airplanes. For example, on a train, it takes about 4 days to travel from San Francisco to New York City, but now you can fly that same distance in just 5 hours. The engines inside of cars and airplanes use other fuels instead of steam power, but they still run on the same basic idea that Hero's engine did, the heat engine. They use heat energy from burning fuel to make things move. We'll talk more about modern fuels and energy in the next mystery. Until then, have fun and stay curious.